Hello everybody. I'll be talking about the work which we have been doing in comp music for melodic analysis of Indian art music. So just to mention quickly, there are three different teams working on this problem. One is from Indian Institute of Technology, Bombay, second one from IIT Madras, and here in MTG. So one of the ways to analyze melodies is through the analysis of short melodic patterns, short melodic fragments. And in the past, it has been used quite extensively in musicological studies. And because of musical connotations, we'll be calling these patterns as motives. And when we talk of Indian art music, these patterns, melodic patterns, are very much tied to the theory. For instance, like every raga, which is the melodic framework, has a set of these patterns, melodic phrases, which very much reveal the identity of that raga. In fact, these are these phrases which are the main cues for a listener to identify a raga. So let's listen to a short audio excerpt, and we should pay attention to two things. First, basically the arrangement in terms of the prominence of the voice of the lead vocalist, and second, in terms of the usage of these fragments, like these melodic patterns. Like here I've taken a very extreme example where like an artist is singing the same phrase again and again, but it will give us some idea how does that sound like. So this is one phrase. So we notice like the lead voice is quite prominent, and the phrases used are like quite improvised. I mean, this is a simpler example in that terms. So in comp music project, we are approaching this problem from both directions, like supervised and unsupervised. If we have a dictionary of these phrases, these reference templates, we can use a supervised kind of approach to find out locations where these phrases occur. And the other kind of methodology where we don't know these reference templates, we discover these patterns in an unsupervised way. And in my PhD, I am basically focusing on unsupervised part without any reference template. And the idea is to devise approaches which we can scale up to at least a data set of size 1000 hours. In comp music, including if we sum up the number of the database size for both Hindustani and Carnatic is already more than 550 hours. So the approach we devise should be able to scale up to that level. So once we have these motives, we want to characterize them. And by that we mean like when we have motive, they have different characteristics, they have different lengths. So we want to transform them into linear spaces where we can analyze and cluster and extract meaningful information from them. And by that I mean characterization of melodic motives. Okay, so this is the block diagram for methodology that I propose. It's a part of my PhD proposal. It's a quite a messy block diagram, but what we should get out of it is it's a kind of semi-supervised approach wherein we want to incorporate in knowledge, domain-specific knowledge, both extracted from the data as well as from the experts. And basically we see that this knowledge is an input to all the processing blocks we have. And there are some external modules which I don't plan to work upon during the course of my PhD, like tonic identification, which I already did in masters, and rhythm analysis, which Ajay will be talking about, but it will be very helpful for this analysis. And these modules are quite generic, as in like they are kind of common to both supervised and unsupervised analysis. And in this presentation, I'll explain few of these processing blocks and the work which we have been doing so far on them. So the first thing we want to do is like we have an audio and we want to extract meaningful melodic features. And the question arises like, what are the good melodic features for this music tradition, Indian art music? And based on observations, we found that pitch, loudness, and timbre of the predominant source are a good starting point. To give you an example of loudness, basically like there are instances in Hindustani music, for example, when the artist sing a very long note, and the loudness is what characterizes that long note. For example, if it's going from louder, like in terms of loudness, high to low or low to high characterizes that note. So we want to take all these features to describe melody, and all these features rely heavily on the extraction of fundamental frequency of the predominant source from the audio. And thanks to Justin and Amelia, like using Melodie, we are able to extract that information quite reliably. So the idea is to extract predominant fundamental frequency of the lead voice using Melodie, and then synthesize that predominant source and use that resynthesized audio to extract loudness and timbre feature. For loudness, perceptual loudness, we are using a model proposed by Zwicker. And for timbre, as of now, we are taking centroid of the spectral envelope, computed using discrete Kapstom based method. Because everything relies so much on estimation of fundamental frequency of predominant melodic source, we did a very quick toy evaluation of Melodie, how well it performs on Hindustani music. So we had annotated data set of size 45 minutes, 6 pieces, and we saw like it performs quite, like the performance is quite promising. The total errors were on this data set were less than 10%, in which around 2% were octave errors. So if we devise an approach which is invariant to transpositions, basically we have less than 8% errors, which is quite promising. So once we have these features, we want to represent them in a way that we have a compact and abstracted representation. And the main idea behind representation is to get rid of surface level musical variations. I don't know if you guys paid attention to the audio I played, like there were small variations which were perceptually not very relevant, like we don't feel that two patterns are different, but if we look them, they are not exact. So the whole idea of representation is to absorb these variations, surface level variations. And currently we are looking at, we have tried 3 different type of representations. The first one is the dumbest, like taking continuous values of pitch, loudness, and timbre. And second one is sax-based symbolic representation, which have been quite widely used in time series analysis. And Joe Cherry Ross from IIT Bombay worked on it, and there was a submission in last ISMIR. And recently we have a representation proposed by Vignesh, which is based on saddle points. It's proposed for Carnatic music, and basically what it is like if we have a melodic contour, the inflection points of this melody are sufficient to compute melodic similarity. So only if we only sample melody at these inflection points is sufficient for computing a reliable melodic similarity. So now we have, let's take an example. We have a phrase from a dictionary of reference phrases, and we have whole melodic sequence. How do we go about searching this phrase in the full sequence? Of course, one way is to do a brute force approach and try to match it with every possible phrase in the melody. But usually these are handled by a process called segmentation, basically segmenting the melodic contour in a way like we get candidate phrases. And for Western classical and for some European folk music, there have been studies regarding the segmentation of melody into phrases, but there's not much work as far as Hindustani music and Carnatic music goes. But we plan to use this concept of Nyas Swaras. I'll briefly explain what's that. So let's take an example of a phrase. This is the phrase in Hindustani music. And the flat regions here, these floor regions, are corresponding to Nyas Swaras, which are resting notes. So it so happens that the characteristic phrases at least end in Nyas Swaras. So basically the offset of Nyas Swaras is a very good salient, it's it's a salient point for segmentation. So we don't get a starting or ending, but we at least have an ending to match our pattern to. And this was used in the same work which Joe submitted in last ISMIR. So now we have candidate phrases from segmentation and a reference phrase. How do we compute the distance measure so that we get an idea of perceptual melodic similarity? There are various ways, and some of the, I'm not mentioning everything, some of the methods and algorithms that we have tried are Euclidean distance. And of course, it's a trade-off between representation and similarity. If the representation is very good, it absorbs the surface level variations. We don't need complex similarity measures. But if the representation has a lot of surface level variations, we need to resort to some dynamic time warping based methods, which have been proved quite useful for this music type. And there have been 2 submissions in last ISMIR and a JNMR submission recently. And for the upcoming ISMIR, there has been a paper accepted which uses the saddle point representation, which I mentioned before, and a rough longest common subsequent based distance measure. So these are some of the things that we have tried as of now. And all the work I mentioned, like the published work, is basically from a supervised point of view, following a supervised methodology. And in terms of annotations, they use these annotations, and we have for Hindustani roughly 750 annotated phrases from 4 ragas, and for Carnatic around 1200 phrases from 5 ragas. But my work in my PhD would be centered on unsupervised analysis, which I started like a couple of months back. I don't have like quite promising results as of now, but my idea was to first implement a very brute force approach as a baseline to compare future approaches with, without incorporating any domain specific knowledge, to try to see what are the problems if we don't incorporate domain specific knowledge. So here is a demonstration video which I'm going to play. It shows repetitive instances of the same phrase which I extracted automatically. So basically these are the phrases which I've extracted automatically without any domain specific knowledge. We see that the repetition is good. It's not that we get any kind of phrases, but the onset and offset of these phrases are not very meaningful. And I think one more. And there are a lot of redundancy, so clearly we need to incorporate some knowledge to make this better. And with that, I think I'm done with my presentation.